Dear students, in this week we will discuss about magnetically coupled circuits. So first of all, we have to understand the subtopics of magnetically coupled circuits. What is magnetically coupled circuit means? So there are three subtopics that we will discuss here. First of all, self and mutual inductance. Second is coupling coefficient and dot determination. So that will be the basic concept of solving the maths. So coming down to the objectives, that how by which means that we can get the learning objectives of this week's lecture, is to understand the basic concept of self inductance and mutual inductance, and also to understand the concept of coupling coefficient and dot determination in circuit analysis. And what is self and mutual inductance? As you know, self means that has been induced, some power has been induced with the same property or same kind of a circuitry. When two loops with or without contacts between them affect each other through the magnetic field generated by one of them, it called magnetically coupled. Just for as you know, as a if we draw a transformer here, if we draw a transformer, the transformer is like this. The pictorial definition will be like this. There is a transformer, there is an iron core here, and there is no contact between these two. There is no contact, but if a voltage induced here, the voltage also induced there, just because of the magnetic force, because of the magnetic force, and that has been magnetic force line. The force lines just induce the power from this coil to that coil, that we popularly known as the secondary coil and the primary coil, as you know. So when two loops with or without contacts, that is without contacts between them affect each other through the magnetic field, means it depends on the magnetic field that creates from the coil, and an electrical device designed to the basis of concept of magnetic coupling and used magnetically coupled coil to transfer energy from one circuit to another. Now coming to the point again, that we have to now pretty much sure about the self inductance, self and mutual inductance. Now coming back, and again coming back to the point, that now what is a self inductance may be. Now there is a pictorial definition of magnetic self inductance. It called self inductance because it relates the voltage induced in a coil by a time varying current in the same coil. Just like this, that's the time varying current, as you can see here. That is as you can see, I can show you by the highlighter. This is the source, the current source, and also the current source, that is a varying current source. So by this, the voltage has been induced here. And as you know, that in that place you can see some of the magnetic lines, force lines, that has been created alongside the coil. So there is a flux, that is known as the flux. So consider a single inductor with n number of turns. When when current I flows through the coil, a magnetic flux phi is produced around it. The magnetic coil also produced around it. So we get this information from there. Now again coming back to our point, that is the self inductance. Okay, so now going to the next part of the slide. According to Faraday's law, the voltage induced in the coil is proportional to n number of turns. Faraday's law will come through to it. That means the flux cut will produce the voltage. So to the number of turns, the rate of change of the magnetic flux will be like this. That is the number of turns n, that is the flux that changes in course of time with respective time, and that will be the induced voltage. But a change in the flux phi is caused by the current I. So the main thing is that is caused by the current I. So we can just put through this that the phi is actually also it caused by the change of current, because that current is varying current, as you know, that is di by dt, that's time varying current. And always you have to keep on your mind that time varying current produces the magnetic field on a circuit, okay, or on a coil. Now just yield the two equations that I have derived previously. Here you can see n d phi di. This part can be written as L. L means from equation 3 and 4, the self inductance L is defined as this. That is the inductance. That the unit of inductance is Henry. So L is equal to n d phi by dt. So we can write V is equal to L di by dt. That means the voltage induced in a inductor is equal to L di by dt. And the units is in Henrys. Now coming back to the another point, is mutual inductance. What is mutual inductance? First of all, self-inductance. Self-inductance means there will be a single coil. Mutual means there will be two inductors or coils are close proximity to each other, just like a transformer. So magnetic flux caused by current in one coil links with the other coil, therefore producing the induced voltage. Mutual inductance is the ability of one inductor to induce a voltage across a neighboring inductor. So that is the ability to one inductor to induce a voltage across a neighboring inductor. So consider the following two cases. There are two cases. First of all, case 1, see that very much carefully to understand the mutual inductance from there. First of all, here you can see that the two coil with self inductance L1 and L2. There are two coils L1 and L2, and they have self inductance, but they are placed in close proximity. That means they are pretty much closer to each other. The distance is very much smaller distance. So coil 1 has n1 turns and coil 2 has n2 turns. So by this coil, that is a time varying circuit, because time varying current has been produced, the voltage induced here, and the from the magnetic power coupling, the magnetic field from there, it will transfer this energy from this coil to the coil L2, and by this coil we can find out we can get the another voltage in N2 turns, okay. The another voltage in that part, we get another voltage, okay. So that is gonna be the point that we have to very much closely understand it. So that is the part of mutual inductance. That means that is case 1. And now turning back to the case 2, magnetic flux phi 1 from coil 1 has two components. So that is phi 1 links only coil 1, phi 2 links both coils. That means there will be two the coils will produce two different magnetic flux lines. That means two fluxes, phi 1 and phi 2. So you have to look over it. That is denoted as phi 1. That is because of this part is a self loop, phi 1. But for self inductance, the magnetic flux just round behind the first coil, and the magnetic flux caused by the L1 to L2 is this point is caused by L1. So that is known as the mutual flux. So this mutual flux is denoted by phi 1 2. That means that has been caused by 1, and you can get from 1. So here we can also proceed from there, that to understand what is the self inductance. You can see that this phi 1 2 that has been caused by from 1 to 2, so it is known as the mutual flux that has been induced here. So now you can see Now you can see uh, 511 means the links only